Hey, it's stream number 3. Got a transcoder. Getting good luck getting the transcoder every night. Probably because I'm streaming late. So this is stream number 3, my project to make my own keyboard. The firmware is going to be all in Rust. And we're using Raspberry Pi's microcontroller, the RP2040, on this Adafruit Keeb or KB2040 board. So this is all we have of the keyboard so far. Let's see. Looking good on the stream. So yesterday was pretty frustrating and stressful because I had a hard drive crash midstream, and I ran into some trouble using atomics on this microcontroller. So it turns out that the exchange and the what do they call it? The CAS atomic operations aren't implemented, or there are no such instructions or capabilities on this particular microcontroller. So things like the spin crate won't work. We have to use different ways of doing atomic operations. So the allocator that I was hoping to use, the slab allocator, depends on spin, which needs those CAS operations in atomics to be implemented. So that didn't work. So I did move to this linked list allocator, and the only reason I'm really using dynamic memory allocation is I kind of want to have formatted strings like this, at least for my log messages. So as far as I understand, both the write and the format macros are in the alloc crate. And if you pull in the alloc crate, you're obliged to provide a memory allocator. So we're doing that with this heap here, which I should probably move into its own module. Yeah, let me do that as the first thing I do here. Also, I think I need to restart Rust Analyzer. I think it's stuck. Let's restart. I reconciled the changes that I made before my hard drive crashed with the ones after, and there wasn't anything significantly different, so I didn't have to make any commit, although I do have... where is it? I do have this stash which has a copy of those changes in it, just in case I do want to pull in the stuff that I had before the crash. So I didn't really lose any data, it's just that the hard drive controller switched off, and right in the middle of everything it just couldn't write any more data. So anything that was in the operating system's write buffer didn't get written. So like the recording of the stream kind of stops abruptly, and then basically I couldn't access the files, and neither could my bot, but I didn't really lose any data that had been there. It's just that I wasn't able to write any more. So, could have been worse. Not sure what's wrong with that hard drive, but I'm ordering another one. It's one of those M2 NVMe drives, so it's like plugged directly into the motherboard, so it's hard to get at without disassembling the computer. I also ordered some enclosures so that I can take it out, put in the new one, and then even when it's out, I can maybe use it as a backup. You know, infrequent use of it, it might still be good for a while. So, yeah, trying to make a good situation out of a bad. Anyway, I don't think anyone's watching. Oh, I have one viewer. Maybe it's my bot. That's okay. I'm going to try to do these streams not really caring if people are watching or not. Yeah, so like I said before, I have a heap implementation here. I had to make this wrapper because this linked list allocator didn't have a version of a struct that implemented the global allocator that didn't require synchronization primitives. Hey there, Volgar. Volugar? More than one. Whoa, now I have 3. So yeah, this thing doesn't implement global alloc, so I had to do like a quick implementation here, and it's just forwarding alloc to allocate first fit and deallocate dealloc to deallocate, and we're just totally doing it unsafe, right? So it's just borrowing, what is this, a ref cell? So this will work until I have threading or I have the second core and we want to share the heap. Then I'll have to figure something out. Let's move this into a module called, I guess, heap. I can spell correctly. So let's see. The extern create alloc needs to remain in the main module, right? But I can grab this implementation of my heap along with the global allocator. And let's grab this part and have this called from a public function in heap. So let me just declare mod heap up here. So the other thing I want to get working is proper logging with a logger. That's sort of like my goal today. All right, so in heap, this is not an entry. This is what I want to make a public function in it. So far, so good. And then in main, I just want to call heap in it. Hold on, why is it giving me problems? Expected bang. Okay. Oh, I don't have a closing delimiter? Okay. Oh, yeah, what am I doing here? I'm kind of blind. All right, let me pull back in this part that I accidentally deleted. These two lines, right? Ugh. Really? What if I just revert? And then delete the lines down to there. That works, right? Heap init. All right, and then I can get rid of some of these imports, right? We're not using box anymore. We're not using that or that. We're not using these. Clean that up. All right. This is using some imports though. Core cell ref cell. Linked list allocator heap. We need core alloc global alloc. And non-null. All right. Build it. And we're going to reflash it. So I'm holding down the bootloader button, toggling reset. You hear my little USB insertion sound. And we're up and running again. Nothing broke. Let me make sure that the serial port's still working. There it is. So we didn't break anything. Beep, beep. Let me check that in. Kind of falling out of habit of doing frequent commits. And I want to do for more frequent commits so I don't lose work when my hard drive fails. So this will be extract. Whoops. Extract heap functions to their own module. All right. Okay, let me try to get this logger working again. rather than doing this elaborate dance, I'd rather just say like info. That's what I'd like to say without the carriage returns, right? And without the as bytes. I want it to look nice and clean here like that. So info comes from log. And it doesn't actually go anywhere unless we have a logger, which is this stuff that I have commented out. So let's bring that back. And this is going to be borrowing our serial port. So I have to establish a proper way to share this serial port. Bring back the logger module. Right, so this is the problem I ran into yesterday, that the ref cell I'm using to hold on to the serial port can't be shared. This thing. So we don't need a reference kind of thing. We do need the ref cell, but I need to figure out how to satisfy the constraint on logger. It's in logger, not logger, but what is it? Log itself. The trait in, I was about to say inherit, but it's really that it's constrained so that it has to implement sync and send. Basically be thread safe, even though I don't really care that it is. I wonder if I can get away with the same trick I did with the heap here, where I just told Rust, hey, we're sync. I bet this won't work, but you know, it's quick and easy. Give it a try. Hey, dude man, an A squared. How are you doing? No hard drive failures tonight. Cross your fingers. Knock on wood. I have another hard drive on order, and I have an external USB enclosure just in case, like, need to transfer files to and from it or swap it out while I'm figuring things out. So the good news is I didn't really lose any data. It just stopped writing to the drive suddenly. So like anything that had been in the right buffer was lost, but I didn't lose any existing data. We're going to be unsafe for a while, A squared, until I kind of have things settled down. Add dying keyword before this trait. Trait objects must include, this should be logger. Okay, that satisfied that error. Okay, so this should just be a borrow mute. Ooh, we're getting somewhere. We don't need reference count. So I just need to put the serial port into a ref cell, right? Use logger. Use log level filter. Okay, so let's put it into a ref cell. I'm still making plenty of typing mistakes because I'm on this new keyboard, this Corn keyboard, and using Comac mod DH, and it's going to take some time. Been using QWERTY for an unheard of number of years. So like switching to Comac, even though it's been 6 months, I'm still making lots of mistakes. Where is my serial port again? Here it was. Right, so when we use it directly, I can just change this to say ref cell. No, I just do serial dot borrow mute, right? I'm having trouble seeing the error because when I mouse over it, it's gone. Oh, it doesn't like the exact type. I think I'm also going to run into a problem because I am passing the ref cell to new. I probably do need a RC, don't I? So that I can keep a pointer to it, or just go unsafe. Yeah, I probably do need that, right? RC here. What? Oh, send. Do I need both send and sync? I just need to switch it from sync to send. Or I need both, I guess. Yeah, I need both sync and send. Yeah, well, suck our escape hatch, right? We're just saying, hey, don't worry about it. Don't worry about it. We're single threaded right now. RC cell standard single threaded shared interior mutability. Yeah. This part is because log is a pain. It wants me to make sure that it's thread safe, even though I only have one thread. The alternative is I can make my own log system. There's nothing that says I have to use this the particular info that's in the log crate. I can make my own thing. It is convenient though, because if I use any third-party crates that use log, then I get to see the log messages from other crates, which would be kind of nice. Okay, back to here. Here I'm gonna have to put it into an RC wrapper. Let's see, new arc would make the send sync happen. Well, but I think I'll run into trouble if I use arc because of what I ran into yesterday. This microcontroller doesn't implement all of the atomics. So if arc depends on exchange, the CAS operations in atomics, it actually won't build. We can try it in a second. That's the problem I ran into with using this slab allocator RS, which depends on spin crate. Spin uses those CAS atomic operations, and it wouldn't compile. Yeah, go figure, A squared. I was shocked too when I built it and it said you don't have an implementation for, was it exchange and compare? I'm like, that's a basic atomic operation. Then I was searching, and sure enough, this Cortex M0 core does not have any instructions other than fetch and store for atomics. It's just got fetch and store. That's it. So I think if we really need synchronization primitives, we have to do the old tried and true method, which is to mask interrupts. It is the primitive. Well, no, fetch and store is the most primitive, right? So exchange and compare is the fancier atomics, and the old school atomics is just you mask the interrupts. Yeah, well, this is a microcontroller. It's not an elaborate computer. We're not doing much. We're just making a keyboard. So I'll probably it's probably what I'm going to do in the end is one of two things. I'm either going to just pick or make some synchronization primitives that mask all interrupts, and so it's absolutely thread safe at that point, or I use the RTIC, which is the real-time something. It's a crate where you get like it has its own synchronization primitives, and it does single-threaded task-based multi or parallel, not parallel, but a task-based system. You know how that ends up happening? You probably want a function without interrupts that takes a closure and runs it in a context interrupts disabled. It's actually provided for us. Let me get my web browser out. That's in the Cortex M stuff. I think it's like... Hold on. I don't remember now. Let's look it up. Yeah, this RTIC is what I just was talking about, where they give us a framework for doing like multitasking with a single thread. Okay, I think this has got it right. Let's see. Interrupt. Or no, it was lock. It might not be in this crate. It might be in the other crate that goes along with this one. It was like Cortex MRT, I think. Oh, there it is. How come it didn't show up in the top? Lock. Okay, now I am confused because I thought it was in one of these. There's a function called lock. Maybe it's here and I'm just too impatient to find it. No, it would show up at the top, right? It could be in... I need to open these anyway. It could be in the HAL crate. Although, I doubt it's here. But I could, you know, could be wrong. Could be here. I can think of where I saw it. It was in the embedded Rust book, right? Embedded Rust book, I think. Aha. Okay, it's Cortex M interrupt mutex. So I was on the right track, I just wasn't searching the right thing. Mutex. This thing. So what you do is you call borrow and you... No, sorry, you don't call borrow. Don't listen to me. Let's just read the book. Yeah, you call interrupt free. And then you give it a critical, you give it a closure, and that closure, the argument you give represents the critical section you're in. And you can use these mutexes within these critical sections. Actually, I'm not sure why you would, if you're locking interrupts, why would you need to do that? I guess I should read this to make sure I understand. Hey there, 715-209. You'd try to use it in my code to see what it suggests. Yeah, I would have done that or something like that if I couldn't find this. Yeah, I need to read this because I actually, on the surface, I don't understand why, if they're running a closure with interrupts, I think that's what interrupt free does. If the interrupts are locked, why would we need to bother to grab a mutex? I guess it's because the interrupt handler also does that. But what happens if you're inside this closure and actually if you're inside that closure, the interrupt can't happen? So this is just a formality that we do this counter borrow, right? Probably to make the borrow checker happy. That's probably what it is. I bet you that this will panic if it is locked and you try to get it inside of an interrupt free. It'll probably panic. I bet you that's what it does. So you get free in this crate. This one. Execute closure F in an interrupt-free context. It's also known as a critical section. So this is like old school critical, or old school atomics. You just lock interrupts and then no one else can run. The idea is that you can't try to access the mutex without the critical section, and you can't get a critical section without disabling interrupts. Yeah. But at that point, if you're already disabling interrupts, then you're not going to get interrupted, so... why do you need to get a mutex? Because if the interrupt handler fired, the interrupts were not locked or masked, so it also knows that it doesn't need to get a mute. See where I'm going with that? Like, that's already the interrupt masking already is a form of critical section, so why do you need to have that mutex? You don't need to, but if your data isn't behind a guard, you could, yeah. That's kind of what I was saying before, right? That's my guess is that they just do a runtime check and they panic. It would be a design time bug, not a not a runtime data bug, but a design flaw. Okay, anyway, I'm talking too much. I changed it to RC. Oh, this is probably because it's moved. There, you can have a reference. Nope, I still have a problem here. Oh, it's because of the type, right? Can I just make it figure out the type from this? Expected mutable reference. Found ref mute. Hold on, is it, close that by accident. Let me read the full report here. Okay, I just think I just need to be explicit with the type. Right? Ref mute T. Serial port. USB bus. Import that. Okay, so here it really does need a mutable reference, so that should be like as mute, or is it? What are the, okay, I need to look this up. What are the methods we can call from ref mute to get a reference if we actually absolutely need one? Alt tab. Ref mute. I can leak it. Making the return reference the only in the... Wait, what? Can you force it with coercion? A mutex is a no checks, it just leverages the critical section token. Oh, that's cool. I'll have to check and see how it does that. Yeah, I guess I can try type coercion. But would leak also work? It's experimental. So we'll try to coerce it. So we're going to coerce it. How did you say to do it? Oh, dereference. Wait. When I just say it as mute. The trait blah 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 as that is not satisfied. Do I need to do that? Non-primitive cast. Consider borrowing the value. Oh. It literally is what you typed. I'm not used to this syntax. I need to mark it as mutable. Yeah, I'm not used to that syntax at all. I see. So it's using deref and then borrowing that thing mutably. Okay, I'd have to think about that for it to make sense to me. Okay, yeah. Here's a problem where when we give it to the logger, I think this consumes it. This consumes self. And I think it figures out that it lives static for a static lifetime there. So if the logger lives for a static lifetime, so does the USB bus. So I think I have to do the same trick I did inside the logger init. I gotta put it into a box and then leak it. Box new this thing. I think I gotta do this trick. Because the logger needs to exist until the end of time, basically. Still says it. Why does it say it's dropped? Isn't this, doesn't this return something that lasts forever? Oh, no, it's A. Can I just be explicit about it being static? Can I just say it's static? Still says it won't live long enough. The explicit deref conversion, yeah. That's why I'm not used to it. It reborrows it, yeah. Okay. It should be living long enough because it's for a static lifetime, but is it that the reference itself ends here? This is saying that the allocator lives forever, but maybe it's saying that this reference doesn't live that long. So let me think about this. To make this work, this needs something that's of some lifetime. In this case, it's going into the logger, so it's going to be the static lifetime. What is it? It actually wants a reference. So can I just put that in a global? How do I do this? Would an RC suffice here? Mem uninitialized. Where did you see that? Is it when I clicked into here? Oh yeah. I think this serial USB-D serial is kind of old. Like this is now obsolete, right? I'm not sure what to do here. Maybe I should study. I've never really gotten the hang of lifetimes. When I think I have a handle on it, and then I try to do some extra stuff that I hadn't done before, and then I come back to this place where I realize I don't truly understand it well enough. Borrowed value does not live long enough. Argument requires the USB bus is borrowed for static, which I thought I did, but it says it's dropped here while still borrowed. How do I tell it? Isn't that a forget or something like that? There's like a trick to tell it to forget it. It's like mem forget. Well, USB, I'm trying not to make it local. That's why I'm doing this box leak. Oh, wait. I forgot to get rid of that. That would do it. No, it still doesn't live long enough. I want this to be something that is a static reference. Is it mem forget? Okay, I have a mutable reference to a USB bus allocator, right? So, what's the lifetime of that reference? Probably it's to the end of the function. even though I told it to leak it. This is my naive attempt. No, it's like saying, I don't care if you say static there. It's not long enough. Does removing it in the call work? Good point. Let's see. Oh, right. Duh. It already is a left reference, so I'm taking a reference to a reference. So you guys are much smarter than me. I feel so dumb. It doesn't need to be mutable anymore because it's got interior mutability, right? And again, we need to take a reference of a reference. Okay, so I think we satisfied the compiler. Now, I have lots of unsafe things, so satisfying the compiler is not good enough anymore. The only way to be sure is to flash it and see if it blinks again. Alright, flashing is good. You see that LED flashing purple, that means our loop is still running, and it hasn't panicked. Yeah, there we go. It does this thing because it fills a buffer, right? And then when I open the serial port, it finally flushes that buffer, and then the buffer's free, and yeah, it can print more. So there we go. We got our log messages working. Yeah, see, A squared knew minutes ago. Okay. It's a good checkpoint, right? Let's check this in. See, this is already, I'm gonna knock on wood, because I was gonna say, this is already a much better day than yesterday. So this is get logging to work, roughly speaking, because we're leaking boxes. Technically, I don't care, because we never terminate the program, and we always want the logger to be there. So it's okay if it leaks, right? Better thing would be to not put it on the heap at all. Can I just do that by making it a global? I think the problem is this, these are not const functions. So I can't make it global without doing, like, what is it? A once cell, maybe? You love the custom sounds? Yeah, the custom sounds are so that people listening don't get confused about the sounds being from their own computer. Think an RC is just as useful here and doesn't leak since it lets any reference exist? Something will have to exist on the heap, almost certainly. Well, can we... I'm wondering if I could put it in the data segment, you know, but making it a global, like the allocator itself in heap. This thing. We can call this because it's a const function. And that means this object, this allocator object, is not on the heap itself. It's in the data segment, right? So it would be nice if I could also put both the logger, where is it? Both the logger, which gets moved onto the heap and leaked, and the serial port, and the USB bus. It would be nice if I could put all of that in the data segment too. I'll make that a task for later. We can change this. Actually, question, should I change the stream title because I got logger working, but I want to keep going? What if I, what happens if I change the title now? Does the VOD get the new name? Actually, I might as well just do it. It's an experiment. I'm going to change the title because we got the logger working. Now I'm going to change it to the next thing I wanted to do, which was I want to see if I can get the button working, and then I want to see if I can turn the button into an actual key press on my computer using the human interface device USB class while the serial port is still working. Because that would be awesome. Because then I'd have a USB composite device that's both a serial port and a keyboard. So serial port for my logging information, and then the primary function being the keyboard. So let's put on a trying to get composite USB working. Okay, I changed the stream title. I have no idea what that's going to do to my VOD, but might as well. Think I'll get a chapter? That'd be nice. Try to use nightly standard once cell API. I'm already using nightly, so I've already opened that can of worms because we have to use that, right? Actually, I'm gonna see just to remind myself what happens if I remove that. I get an error, right, when I build? Yeah. Alloc error handler is required if you pull in, is the moment you pull in the alloc crate, right? And the problem with this is I can no longer build without nightly because features require nightly. Yeah, feature may not be used on the stable channel. I think there is a, what do they call it, an RFC or a work item in progress to stabilize the global allocator and the alloc error handler, and then I won't need nightly. Bot uses the title of the start of the stream. Thanks, Dead Robot Dev. Yeah, we'll find out. Might as well do the experiment. All right. Okay, so I think all I need to do is pull in that other USB class, which I think it is just like this. It's USBD, but HID. Let's make a guess that it's version 0.1 also, and we'll just see. Nope, it's 6, I guess. I love this handy plug into cargo. I forget what it is, but whatever it was that I installed, it's really nice. It tells me without me needing to look it up. Okay, so back in main, I think I just do the same thing as I did with the serial port. So I instantiate a class driver for the human interface. A human interface device, HID, USB class driver on our bus. Let HID equal, we're not gonna need to share this, right? So I can just do whatever it's called. Actually, I need to look this up. I don't remember what it's called. Lib. It's called crates. See, I'm not going to remember that. Okay, my memory ain't so good. I can remember enough to look up the keywords and find it here. Okay. It's probably within here, right? That's not it. What was it? This isn't the right. This isn't the right one. Maybe it is. I guess this is it. Do they have an example? What is the report descriptor? See new for details. I don't know what the report descriptor is. I'll cheat and look up how there's another crate called Keyboron, which is what the Pinchy keyboard uses. I can see that's not it. Is it not Keyboron? I can't remember now. Let's look up Pinchy. It's not in libsrs. It's just in a search engine. Pinchy. Pinchy the keyword, and I want the actual GitHub. There it is. Firmware. Yeah, it is Kiberon. How come? Did I spell that right? I did spell it right. Why does it say parse command line argument by defining an struct? Is that just... Where is that coming from? That's a bug. Allocators still need a ton of work. VOD, oh, yeah, okay. Anyway, I was gonna look and see what this does. Hid. Oh, they implement their own class for it? Okay, they don't even use the same... Maybe I should just use Kiberon then to start with, because it's easier. I thought that they use USB-D hid. No, they use USB device directly. Okay, should I use Kiberon, or should I use this thing and maybe just look up and look at an example? What uses it directly? Oh, I didn't know there was a RP Pico crate. Oh, it's for that board support package, okay. Well, how does that use it? There it is. I wonder what uses it in the BSP. Yeah, they had their crate description wrong. No doubt. HID.
Beep, beep.
It's not... So why is it listed here? Why do they have that dependency listed? That looks like it's an unused dependency to me. Unless it's in examples. And they just didn't put it under dev. Don't the dependencies for examples go under dev dependencies? Here we go. Mouse is a hid. Okay. Okay, here we go. Let's see what they do. So they have a mouse report description. Oh, that's interesting. I'm not doing that exactly. Oh, are they using an option for USB bus? Oh, no, they made it global. That's what I was thinking about doing, but they used option. Huh. I started using that yesterday and someone told me not to, or dissuaded me for doing it that way. I mean, it is sort of a hack, right? Where's this mouse report? What is that? Okay, so it's in a module called descriptor. Oh, it's in that itself. Okay, so then that means here they probably have it under descriptor. Ah, there we go. Okay, so I just need to grab a keyboard report descriptor. Okay, cool. I can do that. I'm just gonna steal from them. Okay. Cool. And I want a keyboard report. It's in a trait called serialized descriptor. So I'm going to pull that in and take the name off as underscore. So how's everybody doing today and tonight? I hope you're finding this interesting. I'm kind of learning as I'm going. Feel free to give me suggestions. I may or may not accept them, but it's always, there are always people out there smarter than me. So that's serial and hid have to go together. I don't think I want the CDC device class, right? If I remember right with the USB, if you have a composite class, you're supposed to use the composite device class, right? It says it should be. Okay. I mean, I can see what happens if I add it. I mean, the fact of doing the side effect of doing that is the USB bus knows about our class, right? So I think I just need to include that in the polls here. Well, let's just include it here. Hid is a mutable reference to hid, whatever the class is. Hid class USB bus. It's looking kind of gnarly, isn't it? Okay, here and here I need to mutably borrow the hid class. And to make that work, hid has to be mutable. Okay, I'm just curious to see if it shows up correctly to the USB host. So let's see what happens. If it works, then what I'll do is I'll try to get this bootloader button, which is tied to a GPIO. I'll try to have that, we'll pull that GPIO and use it to like generate the keyboard report. Okay, so flash. I gotta put it into bootloader mode. Flash it. Well, it's working. Now let's see, do I have a serial port? Yes. I have a serial port. Okay, so beep, beep. The $1 million question is, does it show up as a keyboard in my device manager? Let me look at this off screen first to make sure it's not leaking anything. I don't think it is. Okay, you guys will know that my computer's named Gecko, but that's not going to really help you. Okay, keyboards. How about, because I don't know which one it might be. How about I go to the port? There it is, and then I switch it to connection based. Where's that button? Do I just right click? No, it's under view. Devices by connection. There we go. Ooh. Right, so that hub has, indeed, it has one of my webcams. It has my, my main key. Okay, that's the problem. I have my normal keyboard connected to that same hub, so I don't know which is which. Well, a simple thing would be to unplug it and see what happens, right? Or what happens if I double click on these guys? I could go to hardware ID? Okay, I can see if that vendor ID is the one I'm reporting. Where was that? I can't remember now. Here it is. It's 16C0, right? So that's not it. Is it this one? That's not it either. Okay, so maybe it's not working? Or maybe this is the composite device. This whole thing is my my chip here. Why would it show up head twice and serial port. That's what's weird. Okay, well, I can just unplug it and see what happens. Actually, if I put it into bootloader mode, it'll change, right? Okay, so it shows up under this generic hub. My webcam. This is my real keyboard. Okay. So I don't think it was working then. It wasn't seeing the HID. Yeah, it's just showing up as a serial device. It's not showing up as a HID. So, unless it's this, why is that showing up off to the side? I have too many human interface devices here to figure out which one's which. No, this is what we want to see, right? We want to see composite device with serial port and an input device. Or HID compliant vendor defined device or whatever. That's what I want to see. And right now we're only seeing it as a serial device. So let's double check here. Under details, hardware IDs. Yeah, we see 16C0. That's the vendor product ID. Okay, so it's not working. I'm gonna guess that it's because of this class thing here. What happens if I take that away? Put that off to the side, I guess. Hey, there is Matt. Is the project to write keyboard firmware in Rust? Yes, it is. And today my bot is working. So if you want to read more about it, there it is. So, because I'm a software guy, I'm mostly interested in the software / firmware, but that's going to be the controller I am going to use in the keyboard I'm going to build. So a lot of the time is going to be the firmware, but I am planning to do the CAD work and, you know, think about some of the mechanical stuff too, but I'm going to be pretty weak with that. So I might just take an existing design and kind of tweak it. Okay, what happens if I remember right, composite device is 0, right? So what if I just do this? What does it do? It puts that there, and I want that to go there. Okay. What will this do? Let's see. It's experimentation time. Oh, I forgot to hit enter. Flash. I got USB input device, but I got a non-working serial port. So it kind of worked? Drivers are not installed. And why did it show up twice? Cannot start. Isn't that weird? But I mean, but this worked. It recognizes it a composite device, so it's probably this COM port won't work, right? Yeah. That's one sound I forgot to fix, by the way. Let me change it to COM7. Save that. I'm using putty, by the way. Yeah, it can't open COM6 or COM7, so it's broken. It enumerated it sort of, but it's broken. We are polling it. What else might I need to do? Wait, why did I close that window? I wasn't thinking. Device manager. Oh, that's our device name there. Okay, so if I change this, whoops, if I change this to say like Rusty Keyboard. Build, and then we're gonna flash this thing. Ba-da. Ba-da. Still says serial port. I wonder if it's because it's cached in Windows. What happens if I bump the product ID? Ba-da. Ba-da. Okay, it says we're setting up Rusty Keyboard on the corner of my other screen. Okay, yeah, it was cached in Windows. Okay, so that is the name of the composite device or product. The HID is working, but the serial port is screwed right now. Hey there, Krasner. Nice to see your text. Trying to get my new keyboard's controller to kind of work as a composite device here. We're seeing the product name show up. It looks like Windows is happy that it's a keyboard, but it's not happy with the serial port interface to it. I'm wondering if it has to do with like the order in which I instantiated these. And if maybe I have to do more for it to be a composite device. I'm just experimenting at this point. Like, what happens if I do the HID first and then the serial port? What does that do? I think there's a requirement that this be in the correct order, right? Blah, 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 blah. Must be called. The list of classes passed must be the same classes in the same order for every call. Or it might not enumerate correctly. Strictly speaking, the list of classes is allowed to change between polls that the device has been reset. Because they don't say, like, which device really should go first. They just say it should be in the same order every call. But I'm just going to move it. I'll put it the HID first and the serial port second and see what it does. Prepare to flash. Surely the polling is what actually matters. I would hope so, but there's also these things called descriptors in USB. And I think it gets weird when you talk about composite devices. Because then you have multiple interfaces on the same device. And I might need to look into the documentation of this bus driver to see if I need to do anything special about a composite device. That didn't really help. It's still doing the same thing. Okay. Let me read about USB device builder, and that is in the crate for the HAL? No, it's USB device. Okay, we're going to read about USB device now. USB device. Ignore the fact that it's experimental and it's still under development and not be considered production ready or compliant. This is one of the things I remember reading about. But this alternate settings, I think, is if you have multiple configurations on the same interface. hopefully we don't need that because it's not something I'm not planning to support. They do say one or more classes, so that tells me that they should support multiple classes. It's just how do we do it? Okay. Let's see this firmware complete example. Right, they make the bus, they make the serial class, they make the device builder with the bus, vendor ID and product ID, product name, device class. Is that what I did? Device class. And then build, and then pull with that one in there. And then I made this guess that the device class should be 0 instead of... CDC is like communication device class, which is like serial port is one kind of that. I made the guess that it should be 0 because it's a composite device. Just really quick, what happens if I switch that back? It goes back to just only seeing it as a serial port, right? Flash. Yeah, it's confused now. It's very confused. Out of curiosity, if I comment this out and remove the HID, this should get it working as a serial port again, right? What's the problem? Oh. Yeah, we can't have that. And we can't have that anymore. Okay, flash. Yeah, see, now it sees it as a serial port. Okay. So, the serial port only worked when it was the only class and the device class was here. What happens now if I leave it as a leave it with just serial port and make it a composite? Which, I guess I should look up the documentation to be sure, but I think that's how you do it. This is called trial and error programming. See, yeah, now it's confused. It's like, wait a minute, I don't know how to load this. It thinks it's a composite device, but it's like, I don't know how to enumerate those two. So I must be missing something that goes like, I think it's that has to go somewhere. Okay, let me put it back in. Well, hold on. Yeah, let me undo so I don't lose anything that I wrote before. Okay, there we go. I think I must be missing something here. So I guess I'm looking at device builder and seeing what the methods are here. At this point, I personally would be reading the whole USB spec. I read part of it on the plane. I discovered that the USB specs are the perfect document for me to read if I need to fall asleep. Because every time I tried to read it, I get maybe a few pages in and then I would nod off. Seriously. It is I mean, don't get me wrong. If you're into technology, nerdy stuff, it's pretty fun. But like, it was putting me to sleep. Like, seriously. Anyway, well, so one of these other things, I wonder if I need to call them, right? Do I need a subclass? Oh, class code specified by interfaces. Hint, hint. So how do I specify the interfaces? I don't know. But that's a hint, right? How do I add interfaces? Don't know. Composite with IADs? Configures the device as a composite device with interface association descriptor. This is probably what we want, right? But I need an example that does that. Do they have examples? Let's search their GitHub. Where's the search thing? Do I need to sign in to search? I don't think they have examples anyway. Okay. Let me just not Google search, just go search it. The device. Someone must be calling this, right? Do I need to say Rust? Docs. Was that composite with IADs? I think that's what I need to call. Let me go find that again. Where was I? I have too many tabs. Yeah, so it's the device builder. How come I'm not seeing that? Device builder. Here it is. It configures a device as a composite device with interface association descriptors. And that other hint was that if you use device class 0, it's a class code just specified by interfaces. So this word interfaces, I remember reading that in the USB spec, that if you have a composite device, it's a single device, and then if it supports more than one like interface, that means it can do more than one thing. The other way to do it is I can make it pretend to be a USB hub that has hardwired two devices, a serial port and a HID. But I think that would be a lot more complicated. I need the bus. I need to have it pretend to be a hub. Call it and see what happens. I just don't know what to pass for the. Oh, it just takes self. Okay, good point. I thought that I didn't look here, but I thought it might have. I guess I just assumed it had another argument that I would have to figure out. So sure, let's just call it. I wish they had like examples. Like, here's how you would do a composite device, right? Oh, look at that. We don't have any yellow triangles. It's working. It's a COM port and a keyboard. It's now COM port 11 though. So every time it enumerates some slightly different configuration, Windows is like, oh boy, I'm going to need to allocate another number for this thing. So we're up to 11 now. So I'm going to save a PuTTY configuration for serial port 11 and open it. Oh, look at that. Does the serial port still work? Yes. Now we need to get it to be a keyboard. Beep, beep. So my idea was that this button right here on the lower right. Here, you want to see? You guys want to see? So there are two buttons here. This one's a reset, and this one is marked bootloader. I'm pretty sure that's tied to a GPIO that when we're not bootloading, we can use. Yeah, the beep beep is the Windows ding sound for me. All right. Cool. Let me check this in, because it's working now as a composite device. Git commit. Make USB device composite. HID plus serial. So if I ever meet A squared in person, I'll have to buy A squared a drink, because A squared is always telling me all the like the crucial hints to get stuff working. Just saying, smarter than me. All right, that button. I have the data sheet for it somewhere. Hold on. That was showing me my last project's thing. Okay, I'm gonna duck into my personal notebook for a moment to draw up that datasheet. I really should make a copy of this in the public notebook, shouldn't I? RP2040 datasheet. No, I want the Adafruit datasheet. Which one is this one? This might be it. Let's see. I need to see a pin out. Schematic. Okay, this might work. This might work. Where's that button? LED there. Okay, here's the button. USB boot, right? USB boot is on GPIO 11. Look at that. So if we set up GPIO 11 as an pull-up input, yeah, because pressing the button grounds it, right? Oh, they already have it pulled up, so I don't even need to pull it up. I can just make it as an input. So it should read as a 1 when I'm not pressing it and as a 0 when I am, right? So GPIO 11. Question is, how do I get access to GPIO 11? I guess it would be through the pin stuff, the same way that I got this NeoPixel pin, right? Yeah, so hold on. Let's get access to it. Access GPIO 11, which is the pin connected to the, what do they call it? USB boot button. Bootloader select button. Okay, let, what do we call it? Button. I'm so creative with my names. So it's pins dot, which one of these might it be? D11 maybe? Yep, D11. See, it says pin GPIO 11, D11, and then I think I just do into something, into floating input. Yeah, that's probably what I want. Cool. So what do I got? I got a pin. Let's use the pin. Before I forget, let me put this back onto here. Close that. Okay. Maybe write a comment for future Raimu why you did that, why I did this. You mean like how I knew it was GPIO 11? See, Adafruit KB2040 datasheet. Schematic at the end. Device status and the composite call thing. Oh, that too, yeah. This one? That's a good idea. So, actually, I can put comments in line, right? Name that shows up in device manager. Use use 00 for composite classes by interface. I'm beyond my character limit here. Need this to include interface descriptors. Well, it's interface associated descriptors, right? What do they call it? Interface association descriptors. It's definitely too long. What if I hit format? Okay, so it's defeating my formatter, so I need to fix this. If I just do... Whoop, make that a block comment. No, I messed it up. It's not formatting it. Why not? Maybe this? Okay, so I've confused rustfmt. Yeah, doing normal comments, but it's not formatting the line anymore. It's like confused. It indents that line and it says, whoa, I don't know what you're doing there. I'm not going to try to format that mess. So I'll just, whoop, didn't mean to do that. I'll just pull that out and pull these other things out. Okay, so I'll say that product. Actually, I can just repeat this stuff, right? And I can even use the backticks here. So it'll like, oops. Like that. Future Rima will indeed be happy that I did this. Okay, let's even make it a bulleted list. Yeah, so then it'll be nice and indented correctly. Cool. Cool. Okay, so I have that button. I don't need the CDC device class anymore because we're a composite device. So let's see if we can use the button. I'm just going to read it every loop here and say what it is. Button dot poll or something. Can I do read? What can I do with the button? Get drive strength, get slew rate, clear interrupt, interrupt status, set. Okay, I need to find out how do I use a pin. I obviously don't know how to use a pin yet. It's an input floating. How do I use that? So this is in RP 2040 HAL. Okay. RP 2040 HAL, here we come. Do I have that open somewhere? This was, right? No, this is RP Pico. Too many tabs. RP. Pin. What can I do with the pin? Yes, I am the one and only Raimu here. Okay, so Grants, back when I started streaming, there was another account named Raimu, so I couldn't get that name. So I took the 4 digits from Discord that I got assigned randomly, and I just added it to my Twitch name and YouTube as well. And then after a while, I'm like, I wonder if I can get that name now, because I've never seen this person stream. And lo and behold, Twitch let me pick it. So the account must have expired or something, or gotten deleted. So I'm like, yes, I got the 5-letter account name, which is like next to impossible now. All right. Do I need to call into? No, into mode just turns it into a different kind of pin. There should be something like to get its state. This is just configuring it. How do I read it? I expected there to be a method to read the pin. But maybe it's a trait that's implemented for it. Any pin, channel, clock source, CTS, dyne pin, input. Maybe that's it. Input pin. Oh, there it is. So it'll be an is high or is low. Is high. What does that give me? It gives me a result bool, so we're going to unwrap that. Now we get a bool. Let's see if it works. So it's going to poll it once a second, right on the time of where it is printing that loop message. Okay, so got to open my serial port. Here it is. Okay, so I had the logic reversed. But that's the thing with Booleans. If you get it wrong the first time, you'll get it right the next time. So now I'm going to hold down the button. Okay, there we go. So it's working. I got a working button. So now what I can do is, in that loop, I can turn that button into a keyboard report. What key are we going to make it into? I got the button working. Beep, beep. I'm very unoriginal, so I think what I'm going to do is turn it into the X key. So I suppose that would be here where we poll, right? Polls USB bus for new events and dispatches into bright classes. Returns true if one of the classes may have data available for reading or be ready for writing, false otherwise. Okay, so then I can just say if poll, then we'll just give the HID a report, right? How do we do that? Push raw input? Poll raw report. I don't know how to use this yet. Why do I try to use things before I read the manual? I don't get it. One of these, right? Cortex M, MRT. Hey, there's the RP2040 HAL. Sorry, I found that tab it goes with. Embedded HAL. Which one is this? That's the embedded book. Let's move that over to the left. This is the main. Okay, move that over to the left. That's the main Rust docs. That's USB. Okay, this is it. USB HID. So, how do I use a keyboard? Actually, really, it's a HID class, right? How do I use a HID class? Tries to write an input report by serializing the given report structure. Tries to write an input device to host report from given raw bytes. Tries to read an output. Okay, so I probably want to do this push input, but I need to get a report ready. Figuring out yourself, if you get it right, figuring out yourself is mega satisfying, but you're gonna be frustrated a lot if you don't read RTFM, right? Save you 5 minutes of reading instead of doing 20. I mean, what do you guys prefer? You want to see me read and get it done in 5 minutes, or struggle for 20? You're gonna say struggle for 20 minutes. I know you're gonna say that. What does this poll report do? Oh, that's if we're receiving something from the host. That's like caps lock and junk like that, right? Maybe I need to do that, otherwise the buffer will overflow? I don't know. I can cheat again and look at what Keyboron does, or is it Pinchy? I don't need that. Keyboron. Okay, let's look and see what they do in their HID class. Oh wait, it wasn't this one, was it? Oh, I might have closed the tab. Was it this one? It was this one. In their GitHub, they had an example. Right, right. I need to leave this open. It was this one, Twitchy mouse. But that's a mouse, not a keyboard. Shoot. I might not have an example of a keyboard. Well, let's just see what they do. Oh, I could say manufacturer RIMU if I wanted. I can even set a serial number if I wanted. You know, interesting that they do 0 device class also, but they don't use interfaces. Push mouse movement. What does that do? Okay, here we go. So it's just push input, and the report is a mouse report. Okay, so there's probably something called a keyboard report. Right? I bet you there's something called a keyboard report. Here. Structs. Report type. Looks sort of sparsely documented. How about I just search for keyboard? Keyboard report. There we go. Okay. So there's a modifier, 8 bits, reserved 8 bits, LED, and then we get 6 key codes. That's not a whole lot. Can't hold down more than 6 keys? Really? Am I understanding that correctly? You can only hold down 6 keys at once? I mean, I got 10 fingers. Struggle for 2 hours when you could have read the docs and be done in 5 minutes. But people enjoy watching the struggle. I'm guessing that in USB keyboards you can only hold down 6 keys at once. Not counting the modifiers, right? Receive the status of... Oh, we can receive a report also? Interesting. Well, let's try it. We'll need to know the scan code for something. I can just leave the modifiers. I can leave everything zeros and just... Yeah, let's just try this. So we will first figure out... Let's just form the report. Mute. It doesn't need to be... No, we can do this all in place, right? HID dot... it was push input, right? One of these guys. Push input. Push input. Okay, and the report here, we need to borrow a keyboard report of some kind. Import that. Is push input returns the result, so we're going to drop the result because we don't care. Can't seem to get more than 6 keys. What about the enroll key over keyboard? They are limitless. I don't know. I mean, I guess I could look into the documentation. You ready to fall asleep? I can pop that document up. I got it over here. And we'll just glance at it, just to check it out. So it's the HID version 1.1. There it is. I know you're starting to yawn right away, right? You're yawning. I can tell. Let's just search for report. Report descriptors, page 14. Descriptors. We're too zoomed out to see it. Yeah, this is mind-numbing USB docs. That's okay. Each thing's, yeah, I remember this is about the point where I got tired and started my eyes were drooping. I think what it is you can have many different reports, but there's a size limit to the amount of data. That's probably why they only have 6 keys at once. No? Oh, they have an appendix. That's what I really want. I want like to the, well, I need to see which appendix it is. Keyboard implementation. "14 pages in, 6 of which are table of contents." Yeah. Oh, interesting. Most keyboards should have 8 or more bytes in their reports. That's it? Oh. Okay, example, descriptors, joystick. No, we don't want descriptors. Okay, this doesn't really help. I'm not seeing like a limit of 6. I don't know. Where's this limit of 6 coming from? I don't know. Maybe it's just an arbitrary limit in the Rust implementation of this class. What board is that? It is the KB2040. It's made by Adafruit. It has a Raspberry Pi microcontroller, the RP2040 on it, which is the first microcontroller made by Raspberry Pi. It's the same one used on the Raspberry Pi Pico, which is like $4. These things come on tape reels. You can get them bulk, like in the hundreds. Okay, I don't think we're going to learn anything from that. I'll just figure that out later. So the key codes is an array of 6. So we'll just have like, I don't know, do I put them with zeros, I guess? I can't type today. 0. It's actually really hard for me on my Corn keyboard to type 0, space, because the same thumb buttons are used for 0 and as a layer switch. We're just gonna make all these 0 actually. All right, so then I think we'll just make that one of these slots have the scan code for a key if the button is pressed. So if it's low, right? If it is low, well, it'll be easier to read if we put it here. Let scan, I guess, equal if button is high, 0, else, I don't know, figure it out. Okay, anybody know a good scan code? Hey there, Jackamus, how are you doing? I'm making a keyboard. Here's my controller. You were playing with the Pi Pico the other day? It can handle C++12. It can also handle Rust. What it can't handle are exchange and, what is it? Exchange and compare instructions. It doesn't have those. I learned that yesterday. It's got, for atomics, it's got fetch and store, and that's it. Bool as int exists in Rust. True goes to 1, false goes to 0. 16. What scan code is 16? I kind of want to look up scan codes because someone's going to have me do the scan code for Alt F4 and then I'll really be trolled. Keyboard scan codes. Oh, that's Q. You're close. I was thinking X, but we can do Q, 16. So I should get a Q if I did this right. Every time I hit the button, the bootloader button on that. Build. Flash. Going to bootloader mode. Flashing the thing. Okay, now. Oh! I'm getting lowercase m. I'm not getting a Q, but I'm getting something. Look at that. Every time I hit the button, I get a lowercase m. Why am I getting lowercase m and not a Q? How have I been doing? Doing really well today. Getting a lot of progress today. Yesterday sucked. Yesterday I had a hard drive fail. I learned that I couldn't use synchronization primitives on this microcontroller the way I thought I could. Is it 16 hex maybe? Well, how did we get lowercase m? That's 50. Maybe this is just the wrong kind of... Maybe the report is more than the scan code, actually. Maybe I should be going back to that document. Oh, we're looking at the wrong thing. It's not a descriptor. Oh, this is the wrong thing to read anyway. Shouldn't I be looking at this document over here-ish? This thing? Key codes. But what's a key code? Keyboard button presses to a host and receive the stat. Yeah, but it doesn't say what a key code is. Try reboot it. Is it still M? I mean, okay, we can do... I'm willing to do that. Reset. It's still M. 16 decimals. Is that keyboard layout related? I thought they were just raw... I expected it to match this raw scan code list. I don't know. We can experimentally figure this out. Here's a Microsoft document. Oh, it's a doc. I don't want that. How about... Who do I trust? Scan code from Wikipedia? Oh. It's press and release are... Oh no, these are old keyboard. USB? Use a new set of scan codes mostly specified in the USB standard. Okay, which standard though? So do I need USB keyboard scan codes then? Oh, here we go. Someone made a gist for us. Okay, M is indeed 16. Did you find it too? Did you find the same one? Yep, you found the same one. Did we find it at the same time? All right. Let's save this gist, actually. This will come in handy later. Here are my notes. By the way, if you want to see my notes, notes link will give you a link. So, USB keyboard scan code. I'm terrible at my keyboard, aren't I? That's why I'm building one. I found a fork of the one you found? I mean, I don't have the... Oh, yeah. Why would someone fork this? What project is this? That's weird. Anyway, so Q is actually 20. And if we wanted to say it was a capital Q, we would need to use the modifier left shift, which is 2. Shift. Q. It's funny, when I pressed the bootloader button, it did one last M for the road. Flash. You know what I could do to be really sneaky? I could have it actually type out FLASH, and then I could just hit button and then enter. Okay, here we go. Oh, there's my capital Q. Look at that. I got a 1-key keyboard. We're done. There's my keyboard. I can press Q. Look at that. I can even repeat the key. Look at that. I just hold it down. Let's go. Okay, now we must add more keys. I need 36 of them. On your way to 200 words per minute. All right, let's go. Let's go. Q. Q. All right. This is crazy. Okay, so what did I do in... Oh, come on. Why is it not showing me the diff? I don't get this. Why is it not showing me the diff? Not a hard drive crash. I don't know why my diff isn't working. Oh, because we're somehow in a capital... Oh, that's funny. This thing is holding down the shift key for us. I'm gonna have to reset it. We have shift key is permanently being held down right now. That's funny. Right. It's holding down shift key. I get it. So I have to hold down, I have to counter hold shift? How am I gonna get out of this then? Okay, I'm gonna have to unplug it. So it doesn't hold down the shift key for me. Oh no. What have I got myself into? Okay. Okay, Windows is very confused. It thinks I'm holding down shift. I'm shift clicking everywhere. How do I undo this? I unplugged the damn thing and it still thinks I'm holding down the shift key. Do I have to like press and release an actual left shift key? I have one of those. Did that do it? Okay, that did it. All right. Okay. It's all good. We're all good. Recovered it. All right. Let me fix that before I check it in. Okay. Let's not hold down the shift key if the button isn't being hit. Let's make a let modify. I can just change this to scan in modifiers. Mods and scan. Zero comma 0, right? And this is 2. I can't type. Shift 2 is a Q. Okay. Build. I'll plug it back in now that it's no longer hosing me. Oh, it's hosing me again. I have to plug in while holding down the bootloader, and I have to press the left shift key on my other keyboard there. Funny fact, my Corn keyboard doesn't have a shift key. So I can't actually do that. So now while holding down this button, I gotta plug it in. Okay, I could use a third hand here. Could I do it with one hand? I can. All right. Okay, now I get a capital Q, but it doesn't hose my shift state. We're learning things about keyboards. If you send a report shift nothing, you're holding down the left shift key. Okay, so check that in. Git commit. What are we saying about this change? Okay, we're saying experiment with the bootloader mode button. So if button held down, well, really, pull button once per second and report its state on the serial port. Well, as a log. In the log. Okay, and then emulate shift Q on button press. Release. In keyboard reports. I'm probably sending an excessive number of reports too, right? It's basically pushing this report whenever the host can accept another keyboard report. I need to look up, like, how often are we supposed to send? We should probably only send a report if it changes, right? Otherwise, it's spamming my computer with reports saying nothing held down, nothing held down. Push that. Will you replace your corn with this? Damn right. I hope to make something similar to the Pinchy keyboard, which I have it open here somewhere, don't I? No. I'm more and more thinking that I want to have, how come it didn't give me a direct link? I'm thinking more and more that I want to have something low profile like this. So, yeah, I'm basically, the end goal is to have something better than what I have that is more customized to what I want. So I might go with something with low profile keys this time. And software that I've written myself. Hey there, Red Rampage Crumpet. How are you doing? Yeah, I'm gonna, from the rest of this stream, I'm gonna avoid setting myself into situations where I need 3 hands because I only have 2. Caps lock. Interesting thing is caps lock is something that the host pushes to the keyboard, I think. We can send a scan code to turn on caps lock, but we actually receive caps lock as a report back. Actually, that's another thing to verify here, right? If I have my serial port open, where did it go? Where did my serial port go? Is it not COM11 anymore? Here's COM11. How come I can't open it? Unable to open connection to COM11. Why? Is it open somewhere else? Oh, there it is. Well, that's funny. It took a long time to open up that window. Anyway, what was I gonna say? I forgot. Oh, right. What I can do next maybe is if I get reports from the host, I can print them out here in the serial port. That might be something I can do. And then I can verify that if I hit caps lock on my other keyboard, that my keyboard is told that caps lock state is different. I wonder how frequently we get reports from the host. So that was something that we saw in the docs, right? There was a pull report, right? It's around here somewhere, right? Hid class. Pull raw report, I think it was, right? That's raw bytes. How do I get a non-raw one? So we did push input. Pull is only pull raw output and pull raw report. Use the return tuple instead to determine the buffer's usage. The most common usage of pull raw report is for keyboard lock LED status if an out endpoint is not defined. If output endpoint is not defined. It is not necessary to call this function if you're not going to be using set report functionality. Since I don't understand what this is saying, there must be a different... I must not understand how the caps lock stuff gets reported. Haven't figured out what scroll lock does. In the old days, scroll lock would prevent your keyboard... Well, what did it do? I thought it had something to do with scrolling in a window. Like it either prevented you from accidentally scrolling around, or it made the keys on the numpad into scroll keys or something? I forget. It does light up an LED. That's about all it does these days, right? So what is the set report functionality? That's my question. It's funny that they referenced that same PDF we were looking at and getting sleepier and sleepier reading. Okay, there's not much documentation here. I guess I can start by just like calling this and seeing if we get reports. And then if we do, I can just say, hey, we got this many bytes of reports. How big of a slice? I guess however big I want, right? So let me try this. So pull raw report. We'll do this in the same place. Let bytes equal hid dot pull raw output. Mute data. Let mute data equal... Don't you love it when you hit the wrong keys? 0 U8 64. Why not? So this is a result, right? So we can assume we're not going to get an error, right? Unless it returns wood block. I think I'm just going to keep it as a report and just dump it out. If it is... So if let okay... Actually, I can just combine those two, right? If let okay bytes equal that, then info got bytes of from host as a report. I don't know, too wordy, but that's okay. I hope that this doesn't spam me. Build. Ba-da. Ba-da, ba-da. All right. Where is the window showing up? Where's my putty window going? Oh, is it? Do I have a shift problem again? I do. Wait a minute, did it crash? Ba-da, ba-da. It's crashing. Ba-da. Because you can see it stops blinking. Okay, so it's crashing. Why would it crash? Because it's overwhelming this, maybe? Well, I need to actually put it into bootloader mode. Ba-da. And shift is being held down, so turn off shift. Okay. Oh, I know why it's happening. Because this triggers a borrow of the serial port, which we're already borrowing. Right? No. We should be able to use the serial port from here. No, we can't because we can't log from this delay function because it's borrowing the serial port the whole time. Yeah. So we can't do that. I have to defer that to later. Where should I do this? How about I do this? We'll just have a counter here. Byte count equals 0 U32, and I'll just say byte count plus equal bytes. These are just included here. Byte counter. Count. Oh, I want to capture this, shoot. Oh, it's a U size? Okay, U size it is. Well, does that capture? No, that owns it, right? It's also borrowed as mutable where? $154. Oh, okay, fine. Well, then I'll just do it this way. I hate putting so many things into the parameter list. I'll have to clean this up later. Probably have like a state thing, right? What? Oh. Dereference. Annotations needed. Wait. It knows what the annotation should be. Why can't it just type it for me? All right. Build. Flash. Ba-da, ba-da. Okay, cool. So what am I getting on the serial port? Sorry, what was the chat saying? You join the stream again, all you hear is a big sigh. Are you making a bomb? No, I'm making a keyboard. Later as in never. So future is complaining about the code. If future me is complaining, then I must be doing something wrong. Okay, so there's only one. It did get a 1 byte report. What if I like hit caps lock on this keyboard here? That's not caps lock. That's caps lock. Oh, it got another byte. Caps lock again. Okay, so it's getting a single byte report every time I hit caps lock. What if I just hit normal keys? Nothing. All right, cool. So that report is generated whenever yeah, every time I turn caps lock on and off, I'm getting a byte from the host. So I just need to figure out what that byte means. How am I going to figure that out? Beep beep. I guess I could print it out. So instead of a byte count, I mean, I guess I could just make it a string. So, what to call it though? Reports? Yeah, report. That's what I'm gonna do. Reports. Equal string new. Because you can write into a string, right? Yeah, what I'll do is I'll say if for report in reports dot, well, I can make it a vector, right? I got vectors. I have a heap now. I can make a vector for report in reports info report, and I think I can just put report there and pick the type I want inside the lambda, right? Oh, that's right. Oh, yeah, the right way to do this is vec, right? This is a horrible way to do it. I should like make a ring buffer type. I'm just too lazy right now to do it. All right, no more byte count there. This is the reports. Mutable vector of vectors of U8s. Yeah, so then this would just say reports dot push data 0 to bytes to vec. There we go. Consider importing vec. Wait, I thought I already imported these. Why is it having trouble finding vec? Maybe we don't have string. Oh, shoot. That's not the right thing to import. That's wrong. I imported the wrong thing. Gah. It's not, we don't want vec self. We just want, what is the type of that then? Alloc vec? Hi! One Louise, how are you doing? What is the beep beep alert for? You know the ta-da? The beep beep is just like, instead of the Windows ding sound, the, ta-da is exactly. It's the beep, it's the, ding sound that you'd normally hear. Do I qualify it as alloc vec? So vec is both a macro and a module, right? So do I need to? I hate having to do that. Actually, I can do this manually. It's not as self, right? It's just alloc vec. That should fix it, right? Yeah. Okay. What does it not like about report? All right. So I want to do what is it? Colon question mark to get the debug of the vector. There we go. Yeah. It's been a while. I'm rusty in my rust. Flash. Ba-da. Ba-da. Okay. Let's look at our reports. All right. So we got a 0 byte. Now, if I hit, so I hit caps lock and I got a 2 and okay, so caps lock on is a 2, caps lock off is a 0. Let me try the other, like scroll lock and stuff like that. Scroll lock is a 4. What are the other things you can have lights for? Numlock? Numlock would, hold on, I need to move my other keyboard out of the way. What's numlock on this thing? Function and then that? 1. Okay, so 1 is numlock, 2 is scroll caps lock, 4 is numlock or scroll lock. So it goes numlock, caps lock, scroll lock, and then what would the next one be? We could probably find this now, right? Now that we know what we're looking for. So it's some kind of like modifiers list that has to do with the locks that come from the host. Let me write this down before I forget. So, why is shift being held down permanently? Must be because it's held down right before I enter the bootloader, and then it's never taken away. So anyway, host reports byte. So no locks. That was numlock. Caps lock. Scroll lock. All right. now I'm kind of curious if we could find this. I mean, wouldn't this be in the USB spec? If I like look for scroll or something. There we go, found it. Numlock, caps lock, scroll lock, compose, kana, and then constant. So this is the page we were looking for before, right? So we do only have 6 scan codes per report. Report size 1, report count 8. Report size. Okay, so it's a protocol 1 for HID. Huh. Wait a minute, they say it's reserved, but what did our code show for that? Oh, it showed reserved, but there's an LEDs too. This one doesn't say anything about LEDs. Interesting. So I wonder if this is how we turn on caps lock, is by changing the LEDs there. I don't want to mess with it now. I want to remember what page this is on. This is on page 60. Why do I have 2 of these windows open? Okay. See page 60 of the USB HID spec. Byte 1 is a constant. It's reserved for OEM use. Maybe that's what the LEDs are for? Anyway. Cool. I'm happy doing this much work for today, I think. What are my changes? Just reporting the reports. I'll leave that in there. Yeah, it's almost 11 for me. I could do a little bit more. I just need to take a break. I just need to get up and stretch my legs for a second. Hold on, I'm gonna turn off the camera. I'll be right back. Just needed a quick break. Okay, I'm gonna check this in and then I'm gonna try to clean up that polling loop thing. I don't like how messy it's getting. Git commit. Have a good night, Nightshade dude. Nightshade dude, Nightshade dude. Report. Well, a log message, log host keyboard report, or keyboard out reports. Log keyboard output reports. Bytes. All right. Let's try to clean this up a little bit. I think I can probably bundle this together into some kind of object. Thing is that, yeah, actually, the same object can be rented out to delay and then used down here, right? So let's make an object. What do I want to call it? Like resources or something? Serial port, the HID, and then this reports thing. Lack of a better place, we'll put it here. What to name this thing? This thing represents the resources that we need while we're idle. Well, it's shared between that and our loop. What if I just call it state? The state of our keyboard, really. So into that, I'll put our report. Actually, I'll put all these things here. Actually, I can put the reference count of the serial port directly in there. That's what I can do. This thing, I can just put it directly into there. Like that. Yeah, it can just own this, right? HID class, yeah, why not? There we go. What's wrong with this USB bus? Lifetime specifier needed. That would be static. We established that that has to be static. What, missing? Wait, what? Oh, it doesn't go on the bus. It goes on the HID class? It goes in the HID class. Actually, I didn't make the HID class static, did I? It is not static, so I can just make that generic. That's what I can do. In fact, I can make both the serial port and the HID lifetimes generic. Right? What am I doing? I don't need that there. This is serial. This is HID. Okay, so then I could just make a state down here. Where exactly? Right here. Set up the state of... Set up our mutable state. Let mute state equals state. Reports. Why does it say to do? That should be... Actually, that should just be this. Okay, and then this can just get state. Like this. Okay, and then this is state. Dot reports push. State dot hid. State dot serial. This needs to be borrowed mutably. This should... How was that passed in before? Borrow mute. Okay. Okay, and keep going. So instead of reports, it's state. And this is state dot reports state dot reports. Okay, and there's no hid anymore here. Where's my third argument? What? It's only 2 arguments. Oh, right. No more borrowing the serial directly. Okay. How did I move it? Where was it moved? Move occurs because it has type that which does not implement copy. It occurs on 139. Okay. I can't move it in like that? It doesn't need to be mutable, does it? Borrow of moved value. Where is it moved? Moved on line 163. Oh, where is it used inside here that I missed? Oh, it's right here. There. One more? It's down here. There's a little dot that's sort of like showing me where it is. Okay, cool. We just have a warning. Probably an unused. We don't need ref mute anymore. Nice. Build that. Yeah, there's I think I'm going to remove the shift state from that button because while it's sending the shift cue, it's not releasing the modifier. Which is kind of annoying. Alright, let's see what I get now. Make sure I didn't break it. Cool. So then I can press the button and it says I'm holding it down. If I'm over here and I press the button, I get a capital Q. And if I hit caps lock, turn off caps lock, the report works. Nice. Cool. What if I hit it a couple times? And I get multiple reports. I like it. All right. So I cleaned it up. Do I need to clean up any more? It would be nice if I could get rid of the borrow completely, but I don't know if I can. The problem is I need this closure to get a copy of state. I'm not a copy. It needs to borrow that state mutably. I guess it could be itself in a ref cell. And then I can move a reference candidate ref cell. This whole thing. I don't know. I'll have to put some thought into that. Okay, what's next? I got the USB working. It's a composite device. It's a keyboard with one key. I guess what I should do is put together what are the things that I need to work on next. So let me make a new page here. So this can be areas that need work. So we're going to need to debounce keys. Right? Well, sense the keys in the sense. Because it's probably not enough to be polling them at the USB polling rate. We're going to want to sense them, like get an interrupt when they are triggered, and then we're going to want to debounce them. We need to figure out the TRRS link between controllers. because we're not going to just have one of these guys. We're going to have one per side. How to flash. How to write to flash. I want to learn how to write to the flash for two reasons. One is I want one controller to be able to flash the second. In other words, I want the controller to be able to flash itself when it receives a new program. And then second reason is I might want to reserve a flash sector for non-volatile storage, like for like any settings that I want to preserve between power cycles. What else? Oh, well, we need to do the learn how to design the PCB. So there's a CAD tool for that. We have to do the wiring and vias and pads and all that stuff. I guess I can break this up into sections. So keyboard stuff or key stuff. And this is like board stuff. I keep hitting page down. Sorry about that. Okay. Okay, what else? Oh, the key scanning. I guess that's part of sensing the keys, right? That's probably what the microcontroller is going to be doing constantly. In addition to polling the USB, we're also going to be doing like our key scanning here. I mean, we're technically doing that here. This is a matrix scanning, right? So the way that we would want to do it is you have your keys here, right? We're going to have, I'll probably make these three into an extra column there. Whoop, drop it. These three thumb keys, think of it as an extra column. So we have 6 columns by 3 rows, right? So what I'll probably do is I'll have 3 row GPIOs that we drive low, or is it high? We drive one way or the other, and then we read each of the 6 columns to see which of them are actually the circuit is connected on, and that tells us which keys are being pressed. So that means I'll have 6 plus 3, we'll have 9 GPIOs we have to wire up, 3 as outputs and 6 as inputs. And then that's how we scan to see what keys are being pressed. Oh, I guess we'll also want to figure out pick well, keep in mind what, if any, LEDs to include. Good morning, Romania Hate. I'm just going through like what to do next because I actually got quite far today. I have the USB operating as a keyboard. Look, I can press the Q key. Look at that. I got Q. So all I need to do is add 35 more keys. We also have it operating as a serial port right here. So if I hold down the button, it says button false. Oh, I should flip that logic around, right? If I were to turn on caps lock on the computer or turn it off, I get a report from the host that tells, so we know what our LED modifier state is. Beep, beep. And I cleaned up the code a bit so that now our state is all in one structure. So we have our handle to the serial port, we have our handle to the HID, which is the keyboard. And these are the reports from the host. Figured out how to use that button that's on the board. Got the logging working. We have a heap using the linked list allocator. Oh, I guess that's another thing to work on. All right, I should put that on the list, is how to make the code safe. So that's more like platform stuff, or what are we going to say this is? System level? System stuff? Try to eliminate as much unsafe code as possible. Not just eliminate, but try to eliminate or isolate or encapsulate. Control as much unsafe code as possible. Oh, we have 2 CPU cores, so that's another thing, is try to make use of the second CPU core. The second CPU core. Oh, I also want to verify... Oh, I could do that tonight if I have enough time. Yeah. Verify RAM usage. So we're using part of the RAM for the heap, and there's also initialized data segment, and I want to find out how much we're using. Don't Rust have packages that abstracts the unsafe part for microcontrollers? Yeah, but I still have too much right now, right? I cut some corners. If I search for unsafe, I'm using it too much. I have 9 places where I'm using unsafe, so the fact that I have to take this ref cell and what makes this unsafe? It's this init call, right? Oh, okay, no. It's not that it's in a ref cell. It's that we're using hard-coded addresses for where the heap is. So that one is probably okay, because at some point we have to trust that the memory addresses are correct. Okay, but this I'd like to get rid of. Like, our heap is not technically thread safe. So to make our heap thread safe, we have to have some kind of synchronization scheme for the heap, and also for when we allocate and deallocate memory. They're also unsafe. It's okay now because I'm only using one CPU core and I'm not using threads. If I either do threads or activate the second core and they're both using the heap, this will do terrible things unless I synchronize them. Yeah, so I haven't found a package in Rust at the firmware level that makes the allocator safe for this particular target architecture. So that's something I got to work on. Oh, the other thing was the logger, right? The logger has to implement a trait that's thread safe again. And this fundamentally isn't thread safe because it's sharing the serial port and it's not synchronized. So when I'm using that out here for these, Actually, that's not true. When I'm using the serial port here to pull the USB stack, it's not synchronized with if we were in another CPU core thread handling these logger writes. So to make it thread safe, we'd have to make this serial port access synchronized. Actually, I think I could do that because I was looking into there are a couple crates out there that for this architecture let you make mutexes that are safe. In fact, we already have one. I saw this earlier today. In Cortex-M, there's a mutex type. We could use that. Maybe I could use that right now. Actually, that I can. Oops, sorry. That I can do. So it would be RC mutex, right? No, it would be arc. Oh, right. We wanted to test that. Can I turn this RC into an arc? Maybe not that one, but my theory is that it will not build. Where do we use it? Besides serial port. Don't I use it for something else? This should only search .rs files. It's just a serial port. Okay, so yeah. Let me try changing the RC to an arc. I bet you it won't compile. But then I can fix that by using the an alternative from Cortex-M. Sync alloc. Reload. Oh, right. Okay. Okay, so import that. I bet this won't build. Cannot find sync in alloc. What? Is that's okay, that's not the error I expected to see. It's because inside of the alloc crate there is no sync for this architecture, right? It has to have atomic pointer. Target has atomic equal pointer. That's what it is. Out of curiosity, what do I get if I search for that? Blah, blah, blah. Target has atomic load store. This is a different one. They're different. Weird. Okay, anyway, that doesn't help much. Okay, well, forget that search. My guess is that why we're getting the error is the target we have simply doesn't have this feature. It's not like you can just turn it on. Wish there was. What if I just search for that token alone? Oh, I can just search for this in core, right? Targets supported bit widths. Yeah, I think this is the key to it. Yeah, this one. This is what I learned yesterday, right? ARM targets with thumb v6m, which is us, only provide lower load and store, do not support compare and swap, such as swap, fetch, add, etc. So this target has atomic attribute can be used to conditionally compile based on the target's supported bit widths. So the target we have doesn't have an atomic pointer, I guess. So that's why we don't have access to ARC. So I think the solution was to find an alternative synchronization thing. So the let me look in Cortex-M, because they have, this is Cortex-M. No. This is, they have a mutex, right? Do they have an ARC too? Good morning, Apollo I. It's almost my bedtime. It's 11:24 for me. But I'm having fun and I'm making a lot of progress today, so. Look, I have a keyboard. It has one key. See? I press that button, I get a Q. Whoa. I just need 35 more. So there's a mutex, but is there an ARC? Only safe on single core systems. Critical section is not sufficient to... Sure, that's... I understand that. You don't work Fridays. Lucky you. So we just have critical section and mutex. Okay, so it's send and it's sync. If it's send and sync, then I don't need an ARC. Right? Well, to share it I do. But can't I have a mutex? With a ref cell inside? I could do that. So we would, yeah, it would just be mutex. Let's try it. Because I'd love to get rid of the unsafe stuff that I had. Import mutex from Cortex-M interrupt. Alright, so instead of borrow mute, it's interrupt free, right? With a critical section. And put this in there. And interrupt we have to import from Cortex-M, I guess. No? There. Okay, and then CS is a critical section, right? So... we just call borrow. We give it the critical section. Right. Borrow critical section. No method right for... Okay, so I have to borrow... First borrow the mutex, then borrow the critical section. Borrow the ref cell. There we go. So I love it in Rust-to-Win. Like, you struggle and struggle, and finally the compiler is happy. So I think I can drop the unsafe from this now, right? Yeah, let's try. Well, hold on. Let me fix the errors in this module. So we can't use arc. So this is instead a mutex, which comes from Cortex M interrupt. All right. You can't clone a mutex? Wait, how do I share it then? Oh, is it not shareable? Dang. Okay, then, how do I get it? How do I share it? Are its methods all... Okay, you don't need mutable access, so it can just borrow it. It can just borrow it. So I need to change it to borrow the mutex. My watch is telling me it's time to go to bed. So borrow the mutex. That means this needs to have some kind of lifetime. Serial. Right, so we'll need this everywhere. Oh, but hold on, that need to be static. Yeah, right. Logger is gonna live forever, so that has to be a static. How am I gonna do that, though? How am I gonna put that into the static scope? I'm leading myself into a trap, aren't I? Right, so I need to lock interrupts when I do this, right? So let ready equal that if ready. So then here I can say interrupt free CS let ready equal that. Put that in there. And this is let serial equal state.serial dot borrow with the critical section. Sure. And just do that much of it. That comes from Cortex M. Okay. Yeah, this has to borrow this. That's, I think I'm gonna have trouble with that. Borrow? Yeah, it doesn't like that at all. Whoa. It's got the... Oh, right, because this is serial. I can't do that, though. Doesn't live long enough. That's what I was afraid of. It's dropped at the end, but it's still being borrowed for the lifetime of the logger, which is static. So I guess I will do the same trick that I did for USB bus. Box leak, box new. Put it on the heap and forget about it. So the type that will be a reference, so I don't need to do that. And that can go back to being that. Ooh, I got it to compile. All right, let's remove the warnings. Okay, let's make sure I didn't break it. Ah, dang it. Shift key. Okay, it's still blinking, which is good. That means I didn't break it. Okay, so there's the reports. Let's see if I can... Okay, it's still working. There's my cues. Cool. I like it when I don't break it. I like it when I don't break it. So, now, all of that was an attempt to get rid of this unsafe. See if I can finally do that now. Yes! It's safe! It is safe now. We have one less unsafe. We still need that unsafe because setlogger racy is unsafe. So we're making a pledge that it really will be static lifetime, right? It's only safe to call when no other logger implementation is called while this function still executes. Okay, so we're just taking on the burden of ensuring that we don't register another logger, and that there are no other threads, and that interrupts are disabled. Well, I guess I can lock interrupts at this point. Yeah, why don't I just lock interrupts here? Interrupt free. We're not going to need this critical section. Got to the point in your game where all the features you want are in and not just expanding and adding content, so 6 months of that and the version 1 should be ready. Exciting times. Cool. Way to go, Apollo I. I'm starting to feel really good about this project because when I think about it, there aren't a whole lot of things here to figure out. We're basically doing this now. These are kind of extra. I don't even really need to do those. Soon I'll really be done with the firmware because all I really need to do in the firmware is do this and this. This is extra. This is extra also. I mean, pretty soon I'll be doing the CAD work for this thing. Get the board printed, mount the switches and the controller on, wire it up, and then we'll be getting these things. Actually, I guess before I get the board back, I could have 2 of these controllers and work on this thing first. The TRS link is the this cable between these 2 halves. It's how the 2 halves will talk to each other. And I took a peek at what the Pinchy keyboard uses, and they use a one-way UART, and we can do that too. You just run a bidirectional serial port on it, and we can send reports back and forth. Okay, so one less unsafe thing. Now this increases our guarantee of safety. It still wants me to say unsafe, right? If I get rid of that, it's going to have trouble. It's going to say it's not safe, right? Unsafe requires unsafe. Okay, yeah. But like this says here, for safety, it could be upheld by making sure interrupts are disabled. Okay, so maybe I should mark this then. Yeah, I think every time that I've done as much as I can for safety, I'll put a comment. I'll say this, oops, this should be safe now since we disable interrupts around this call, and presently we don't enable the second CPU core. All right, so that's annotated. This one will declare safe. This should be safe. That's probably not the right language, right? What's the correct language for saying that you reviewed something that's potentially unsafe and you're pretty confident that it's safe now? This should be safe as long as the memory region we grant to the allocator will never be used by anything else. I think that's what this init says for safety, right? Okay, they don't actually say. But, oh no, that's because it's my function. Yeah, must only be called once. So we should also say that, right? As long as this function is only called once. So hold on. I can get rid of this unsafe. No, this intrinsically is unsafe. We allow it with that. Okay, so these we can't fix yet without I guess I can use the mutex here, or I could interrupt lock them. Yeah, why don't I do that? There's no that it yeah. Interrupts free CS not used. This. So again, what this interrupt free does is it prevents hardware interrupts from happening while we're executing this closure. So with interrupts masked and they're not happening, then as long as it's a single core, there's no way that there's no way that we can re-enter this allocator. Because presumably you use interrupts to do task switching. If we introduce a second core, we have to go a step further and kind of like have a spin lock, interrupt lock thing to prevent the other core from going in here too. We'll deal with that when we get there. Actually, now that I think about it, I could make an abstraction that calls interrupt free, and then we can have it do this for now, and then later we can make it do a spin lock instead. What did I do wrong here? Oh, another parentheses is needed there. Okay, so do those need to be marked unsafe? Yeah, because they're marked unsafe in the trait. Okay, so there's not much we can do. I can just mark that this should be safe now. And I've done that before, right? Yes. I'll use the same excuse over here. And here. That these should be safe. Since we disable interrupts around this call presently, we don't enable the second CPU core. And does that unsafe keyword need to be there? Yes. But this I should be able to remove, right? No. Why not? Oh, because I'm using a ref cell. Look, okay, we can fix that though. Right, I can make this into a mutex ref cell. Then we can get rid of one more unsafe thing. Import mutex and core. Interrupt mutex, and then we need to put a mutex new here. And then here in it, we got to do an interrupt free. We're actually using the critical section this time. And that's to add another borrow at this point with the critical section. Okay, and then here again, we'll need to use the critical section. So we borrow the mutex and then we borrow the ref cell. And same thing here. Cool. So I got rid of another unsafe. So our heap is now send and sync because we use a mutex around our ref cell. Awesome. Let's make sure I didn't break anything. Build. I should fix the shift state on this thing. Bada. Cool. Still working. Okay. Let's check that in. I made a whole bunch of things safe, right? So git commit use mutex to and interrupt free. Let me put ticks around these. Well, let's just say employ, because that sounds cooler. So, using use interrupt free to make critical sections and to make critical sections basically, and then use mutex within critical sections to allow to permit thread safe caveat single CPU, single core, access to shared resources. This button? No. This one. There we go. Wrapped it. I like that. Git push. Okay, there's two more things I want to do tonight. I want to clean up one miscellaneous thing. Beep beep. Wait, why does this say I have unsafe changes? Hold on. Did not all my changes make it in? Oh, that's an accidental change. I hit G by mistake. All right, so I made an error down here when you push the button down, it says false, and when you're not pushing the button down, it says true. So that should be low instead of high. And the other one is we're turning on the shift state when we press the button, and it's getting stuck on when I reprogram the thing. So let's not mess with shift anymore. We'll just make it be the scan code again. It'll just be a lowercase q. Mods will just be 0. It's just easier that way. Build. And one more time to mess up the shift state, and then that'll be it. Unmess it up. Okay. Flash. So it'll get lowercase q's now. And if I go to bootloader mode, it doesn't mess up my keyboard state. Okay. Make sure the COM port still works. I wish that putty wouldn't like throw up an error and then not work anymore when the COM port goes away. Cool, so it says false, and if I hold the button down, it says true. Caps lock detect still works, right? Yep. Nice. All right. So this commit is just some minor cleanup, right? So some minor cleanup. Don't assert left shift on button press. Because this makes left shift stick in quotes when we hold down that button and reset the controller to get it into bootloader mode. Okay, and the other thing that I did was flip the button state when reporting it every second. All right. Push that. Cool. So I made a lot of progress. I don't know. I didn't think about what I'm going to do tomorrow. All of these sound fun. This should be easier. Maybe I'll start with this, and then so just we'll check out how much RAM we're using, and maybe there's one opportunity to clean up is in my heap. I have hard-coded the RAM addresses of the heap. We could actually leverage our linker script here. We don't have symbols here, but we could add symbols to track the beginning and the end of the data, the initialized data, and basically reserve everything else in RAM that isn't being used for data for the heap instead, and just make sure it's you know, page aligned or whatever we need to do. And then I don't need to hard code these numbers here. We'll just get them from the linker. That's something to work on. What's that in the background? TV? I have kids around me who are talking and stuff. Maybe you heard my son yell goodnight. But yeah, I can work on that tomorrow. Second CPU core sounds fun. I'm not sure what we do with that second CPU core yet. Actually, one thing we could do is we could have one CPU core just do the USB, and the other CPU core just do the keyboard scanning. That might be useful to do. The one core could do the USB and all the logging and stuff, and the other core could just be dedicated to matrix scanning, because we kind of want something to be scanning very frequently and not get distracted by USB, right? So that could be a plan. The only other things I can do before I get into the CAD stuff would be try to figure out how to use the flash, because that'll allow us to more easily program the other half of the keyboard, and also use non-volatile storage. And then this will be fun. I might do this sooner because this is more approachable. I just need to have a second controller and connect them via GPIOs and just have them talk to each other with the serial port. Although it would be convenient to do this one first, because then I won't need to have both of them connected to USB. I could have them daisy chained through UART. So it's sort of a toss-up which of these two I do first. And then I think I'm going to wait to do these until I wire up some key sockets with the switches. These guys with the actual keycap. So this is what the socket looks like. That's what the socket looks like. And the I need to take a couple of these sockets, if I can get it lined up right. They're just basically got two little plugs where the switch goes in, like that. And it's got two leads there, and I need to just take the two leads and solder them to pins and put them on the breadboard, and then wire that to the GPIOs, and then we can play around with sensing and debouncing. So we can do debounce first, because I only need one key to test debouncing. Sensing, though, I'm going to need a matrix of keys. At least 3 keys, right? If not 4. I'd probably want to wire up a 2x2 to test that. Yeah. So there's a lot of things to work on. I'm just trying to get a sense of like the order in which I'm going to do this stuff. But yeah. Anyway, am I done with checking stuff in? I forgot to check stuff in yesterday. Okay, we're all checked in, so I'm good to go for tonight. Thank you for watching. Let's see if there's someone else we can raid. And I'm going to go to bed. Let's see. Hey, let's raid Adam C. Eunice, because I like his stream. Completely different stuff, but Adam's a nice guy. Okay, I should be back tomorrow. I'm having a lot of fun doing this series already. So I hope you enjoyed watching me figure things out. Today went a lot better than yesterday. I'm happy about that. Hopefully I have more progress tomorrow. And this will soon turn into this. It'll happen before you know it. Okay. Have a good night or a good day. See ya. Bye.